Hey guys, today we're going to be looking at some particle acceleration, and specifically this time we're actually going to look at it when we've got the acceleration function, which means a bunch of integration. So we know that if we've got a particle moving on the x-axis, it's given by this function for our acceleration, and we also know that at time equals 0, our velocity of 0 equals 1, and our position of 0 equals 0. Now I'm going to change this x function to p because I think that that makes more sense for us, having the position function be p of t. And the very first thing it asks us to do, of course, is find the velocity. So really what we need to understand here is that the velocity function is going to be the integration of the acceleration function. So what we need to remember there is that when we integrate cosine, it becomes sine, not negative sine like it would be when we're doing the derivative. And then because there is going to be like what would be a chain rule here, we're going to need to divide by 2 in order to eliminate that derivative that will eventually be multiplied by it. So, and then of course we need to add c. So to simplify it a little bit, we're going to get that it's equal to 2 sine of 2t. And to figure out what c is, we're going to have to use that v of 0 equals 1. So we know that 1 is going to be equal to 2 sine of 2 times 0 plus c. Well, sine of 0 is just going to be 0. So c is literally 1. So our velocity function, therefore, is going to be 2 sine of 2t plus 1. You can probably guess the next part they're going to ask us for is the position, right? Usually we want to have the position, velocity, and acceleration functions. And so sure enough here, you can see they're asking us for x of t, which we're going to relabel as p of t for our position. So we're going to integrate that thing that we just found there. So really, again, p of t is really the integration of v of t. Okay, now from here we need to remember that the derivative of sine, okay, sorry, not the derivative, the integration of sine gives us negative cosine. So in this case, we're going to have 2 times the negative cosine of 2t plus the 1 is going to become a t. Sorry, it looks a little bit confusing there. We'll get rid of that. There we go. And then, of course, plus c. Now we'll simplify just a little bit so that we don't have it look kind of funny there. We'll put the 2 and the negative cosine together. So we get negative 2 cosine of 2t plus c. And then we're going to use that fact that p of 0 was equal to 0 to solve for what c is again. So 0 is equal to negative 2 cosine of 2 times 0. Plus 0, we're just changing all of our t's into zeros here because of what this tells us up here. And so then we can go ahead and look at this. Well, obviously adding 0 does nothing. However, this time cosine of 0 is going to be something, and it's going to be 1. You know what we forgot? When we're doing the integration here, because there is that chain rule, we need to divide it by 2. So in reality, this would actually simplify even further to give us negative cosine of 2t plus t plus c. So that means that over here we need to get rid of this 2 there. All right. So we've got this cosine of 2 times 0 is just negative 1 plus c. When we move that 1 over, we get that once again c is equal to 1. All right. So our entire position function then is going to be negative cosine 2 of t plus t plus 1. All right. Now, last thing we want to do is figure out when the particle is going to be at rest between 0 and pi. Okay, so we're going to restrict our domain, just look at our time between those two things and figure out when it's at rest. Well, to be rest, it needs to have a velocity of 0. So what we need to do is make sure that we set up our velocity of t needs to be equal to 0. So let's write down our velocity function again, just so that we remember it. And so our v of t, actually I can't remember it, let's just look up, 2 times sine of 2t plus 1. 2 times the sine of 2t plus 1. Make that a little more obvious as t. There we go. Now we need to figure out when this thing equals 0. So 0 is equal to 2 sine of 2t plus 1. Then we're going to need to do some algebra. We're going to move over this 1. Get that we've got negative 1/2, because we would also divide both sides by 2 here. Negative 1/2 is equal to sine of 2t. At that point, we need to figure out, okay, well, when is sine going to be equal to negative a half? That happens at 2 times. That happens at 7 pi over 6, and it's also going to happen at 11 pi over 6. However, we need to remember that what it is it's not t equals these things, it's when 2t equals those things. Therefore, if we think of those two things separately, we've got 2t is equal to 7 pi over 6, which really means that t is equal to 7 pi over 12. And the other one would be 2t equals 11 pi over 6, which means that really t is equal to 11 pi over 12. So those would be our two places where it's going to happen. Guys, I'm going to make a quick comment here. So you obviously saw that when I was up here doing this, I had made a little mistake and I forgot to actually divide by 2 here. Part of the reason I didn't reshoot the video is I think it's important for us to see that it's all right sometimes to make these mistakes and just go and correct them, right? It's not something we need to beat ourselves up about. It's, you're working with a bunch of numbers. It's not a big deal, right? Instead, what we want to do is just catch them, learn from them, and then hopefully we make them a whole lot less in the future. So I wanted to just kind of highlight that, and that's why I left it in the video, because I want you to see that calculus is not something that you just get perfectly all the time the first time. It's okay to make a small mistake. Just try to, catch it when you do catch them, go back and fix them. Don't beat yourself up, just fix them. All right, guys, that's going to do it for this one. If you found this helpful, don't forget to like and subscribe. Tell your friends about us. We also offer tutoring services, so feel free to reach out to us. Look for Momentum for Life, and let's keep this momentum going.